Welcome to the Adabas Parallel Services for Unparalleled Performance and Lowered Cost conference call. My name is Adrienne, and I'll be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we'll conduct a question-and-answer session. Please note that this conference is being recorded. I'll now turn the call over to Debbie Goltra. Deborah Goltra, you may begin.
Good morning. I just want to warn all of you that I have more information on these slides than we can do in our time frame. So I might skip through a couple of the slides. The talk is about Adabas Parallel Services and how I used it at a state agency to save some money. It doesn't happen very often, so it's pretty impressive. Let me just give you a little bit of background about our company. I'm on the State of Texas contract with Xerox Corporation. In 2005, the Texas legislature decided to save some money and outsource the data centers and management of 28 of the state agencies. There are 55 total, and 28 of them were outsourced into one data center. The Texas Department of Information, or DIR, manages the contract, and the goals of the contract are to reduce IT costs and to provide reciprocal DR costs. Before this point, each of the 55 agencies had separate DR contracts with different outsourcing vendors. 8 of the agencies are mainframe and mid-range combinations, and 5 of the agencies have software AG products. The original contract was awarded to IBM in 2007, and they took over the San Angelo data center that Northrop Grumman had been running. 4 of the agencies were on mainframes in the San Angelo data center. IBM created the Austin data center to give us the reciprocal data centers, and they moved the other 4 agencies out of Austin state office buildings into the Austin data center. Mid-range machines are being gradually moved into San Angelo or Austin data centers. In 2011, the contract was rebid and was awarded to Xerox. So I moved from the IBM contract to the Xerox contract and stayed on site. One of the big contracts for the Xerox rebid was to upgrade the mainframes on all of the agencies. I'm going to focus on just one agency right now and their experience with Adabas Parallel Services. The agency has asked me not to name them directly because if I had done that, then this whole presentation would have had to go through their legal department for approval. So we're just going to refer to them as the agency. We are running on 3 LPARs on an IBM 2094-603 processor, running ZOS 113, CICS 3.2. We've got Adabas 824 and DB2 version 8, and we're running at WebSphere. The software AG products, in addition to Adabas, are Adabas Delta Safe, Caching Facility, Natural 426, which is being upgraded to Natural 823, Predict, Broker, Entire Network, lots of Treehouse products, and an important part is Adabas Triggers. Let me just give you a quick overview of the databases. On the production LPAR, and we do run production separately on a different LPAR than development. So on the production LPAR, we have 8 production databases. One is a database of system files only, and we use the UDB parameters to point to different operational data. The main database is the I've labeled the main operational database. It runs on about 700 volumes. If you can notice, it's the second one in line. We refer to it as Database 11, and it's 1.7 terabytes in size. We also use an FTP database for incoming transactions from other government agencies, including the IRS. Then we have some operational data that's been summarized into some management reporting, and they use SAS to do a lot of this reporting on the management reporting database. We have a full clone of the main operational database that they also do a lot of reporting from that is rebuilt on a weekly basis. The development databases that run, the 4 production databases are mirrored to an alternate site. These are the ones that we recover during a DR test. So we mirror 4 of the databases to the Austin Data Center from San Angelo to Austin, and that's the system file database, the main operational database, the FTP database, and the old data. Those are mirrored in real time, and we flash them. This is really weird doing this presentation without seeing any faces. Just to give you an idea, on our main operational database, the database 11, we run about 10 billion commands a month, and our average CICS response time is right about 0.03 seconds. The database stays up for 24 hours a day, 7 days a week. We take it down once a month to do an IPL, so it's down for about 2 hours in any given month. Note that we have over about 13 billion records on that database, and of the 300 plus files, 104 of them are over 1 million records each. On our development LPAR, we have 43 development databases. 2 of them are full clones of the production database. Others of them are clones of various things, and they are checked out and used by the application teams to do testing. We have 2 databases on a sandbox that I get to use for installation. Our current machine, or at least it was current last year, was a 2094-603. It had 1,332 MIPS and 184 MSUs. The configuration folks figured that there were 2 good candidates, because the whole focus of this presentation is the choice we made on the CPU for an upgrade. We could go to a slightly smaller machine, a 2817-406, that was, like I say, more engines but smaller, or we could go to a slightly larger machine, which would give us fewer engines but larger ones. The MSUs on the larger machine were about the same size as the MSUs of our current machine, but the MSUs on the smaller machine were much smaller. When our capacity planner did a little analysis, he could see that the current machine, they did not use all of the MSUs or the MIPS on the current machine. That's the green bar or the top bar running across the slide. But they were slightly over the MSUs of the smaller machine, and that's the red bar. His suggestion was that if we could somehow get multiple processors running against database, we could probably do a better job. He explained it as a ditch digger. If you were running one started task like we are currently, that is like one guy digging a ditch. So your single task control block is the ditch digger, and if you could somehow get multiple people or multiple started tasks running, it would be like having multiple people digging a ditch. It would be faster and bigger. We found out that an Adabas starter task runs in a single task control block. So if we could get multiple task control blocks running against the same Adabas, then we could probably go on the single machine, on the smaller machine. The agency, we wanted to know if they'd be willing to license additional software, and if the cost of the additional software for running multiple Adabas sessions would be the same or less than running on the larger machine. That was our trade-off. If we went to the larger machine, then the licensing fees from the third-party products would be much higher than if we went on the smaller machine. We found that Software AG provided 2 different products, Adabas Parallel Service to run multiple sessions on a same LPAR, or Adabas Cluster Services to run multiple sessions across LPARs. Since all of our databases, our production databases, ran on the same LPAR, then Adabas Parallel Services would suit our needs. Both cluster services and parallel services require global buffers for caching and lock management, and the cluster services uses the coupling facility to run those cache and lock managers. Adabas Parallel Services uses data spaces to run the caching and lock managers on the same LPAR. And Adabas Parallel Services was already bundled in our Adabas licensing. For American customers, that product has been bundled for quite a while. Since all of our production databases run on LPAR, Parallel Services was the best fit, and we already paid for it, so there were no additional fees for us. The agency had already used Adabas SMP, the serial multiprocessing product, about 10 years ago, and they were not thrilled with that. They installed it and then took it out. They were very unhappy that with Ada SMP we had one update nucleus and multiple read-only nucleuses. The BT logic was very inefficient, and anytime backouts were done, it really slowed things down, and there was a relatively high overhead for running Ada SMP. We had a conference call in December of 2013 and talked with Becky Albin, or I guess it was 2012 actually, and had a long talk with Becky Albin, who assured us that Adabas Parallel Services was a very different product. Software AG basically threw out Ada SMP and derived parallel services from the new cluster services product. All of the started tasks are update nucleuses, so that was one huge difference. It didn't matter which task they were routed to. It could process both update and read commands. The backout logic was very efficient, and the overhead varies, but Becky told us it was about 10% or less. So this was our time frame. We would install the parallel services in our sandbox in December of 2012 into development in February of 2013, and the goal was to get the parallel product into the production databases by June. We needed to make the decision on the new processor and have it installed in July so that we could do a disaster recovery test in September, and we wanted that disaster recovery test to be on the new box with whatever configuration we were going to use. So our goal was to get the new processor online and the parallel services products all installed for that DR test. One thing I had to learn, and I had to sort of rethink the way I think about databases. I used to think of the database as the starter task, and I really had to change that. And the database is the DBID that lives in the associator and connects to data storage. That's where the database is, not the starter task that runs against it. So that was something that I really had to wrap my head around. And when I read the documentation on parallel services, the documentation is a little fuzzy because they talk about parallel services and cluster services with capital letters, and then they talk about cluster databases. Well, a parallel database is a cluster database as well. So when you're reading the documentation, all the stuff that they talk about on cluster databases with a little c refers to the parallel services databases as well. So you're going to have multiple started tasks connecting to the same physical database with one DBID. You're going to have a new parameter called a nucleus ID, which is going to be assigned for each parallel started task. And each nucleus ID is going to have a separate work data set, plog, and clog data sets in the JCL. They'll all talk to the same data storage and associator, but each started task will have its own work, plog, and clog. Then you will also have a new started task to run the Adacom utility, and that manages all the routing. So if you think of this in server terminology, we're now going to load balance through an Adacom utility, and he will handle all of the communication to the parallel sessions. So the Adacom is your dispatcher, and he will dispatch users, and he will try and keep them balanced to each of the parallel nucleus sessions. One concept to keep in mind is that each parallel session should be able to handle the entire workload. If you had a failure of any one nucleus, then the remaining nucleus should be able to handle it. Or if you wanted to take a nucleus down, your remaining nucleuses should handle it. We were going to start with 2 nucleus sessions, so that was my mindset, that I would always have one up, but I could take one down if I wanted. And there's also a new concept called the PPT, the Parallel Participant Table, where information is stored for restart and recovery. And even if you're not running parallel services, you still have a PPT running in your database. One thing that I was really surprised, I thought this would be much, much harder, but the installation was really very simple. One thing I did is I retained all of my single session JCL, my single session parameters, and my single session user exits, because I wanted to be able to go back and forth between single sessions and parallel sessions. And during the installation, that was very, very important, and something I did quite a few times. The hardest thing I had to do, and the hardest part of this installation, is determining a naming convention that will suit your environment and allow you to easily relate your parallel sessions to your data sets and your parameters and keeping that all together. I talked with Rich Crumley at Morgan Stanley, and he shared his naming conventions, and they use letters to relate back to the nucleus IDs. So nucleus 1 gets letter A for all of its data sets and JCL and parameters. And nucleus 2 gets the letter B for all of its parts and pieces. And the database 11 nucleus, the database DB ID is always part of the nucleus numbers. So a nuc ID 1101 belongs to database 11. And nucleus ID 1102 also belongs to database 11. I left the parallel session, or the single session for nucleus, for database 11 alone, and so the single session database for database 11 defaults to nuc ID 0, and you don't put that parameter in, but everything else stays the same. To do the installation, you create new JCL, you create new data sets for your work plog and clog, and you want to make them exactly the same size as your single session databases. Again, you want to be able to go back and forth very easily, and you want to always keep any parameter change you make to your parallel sessions. You also want to make it back to your single session and vice versa. If I was running a single session and I made a parm change, I would want to make sure that to change my parallel sessions if that was appropriate. And you want to create a new UEX2 or UEX12, depending upon whether you're doing dual P-logs or multiple P-logs, because you want to have a JCL in your user exit that's going to reference your new data sets, and then the new merge-in data sets that you need for parallel sessions. One thing that you will learn as you read the documentation is when you do a P-log switch, the databases, the nucleus sessions can decide to switch all at the same time or wait later, and they will roll all of the transactions together through these merge data sets. So they're very important. One data set handles all of the transactions coming in that will be merged into a combined P-log, and then one of them is an output data set for transactions that don't meet the timestamp. So you've got to keep these merge-in data sets coming in and going out for all of your transactions, and Adabas handles this automatically for you, so you really don't have to worry about it too much. One important parameter in your ADACOM is not only the DBID that you're running in parallel, but the total number of users that can go to all of the database sessions. So if you have an NU parameter in your database nucleus, the sum of all your NU parameters of your individual sessions should be listed in your ADACOM. So if I have an ADACOM of 10,000 or 20,000 in this example, my NU parameters in all of my nucleus sessions should total up to or be less than NU. So if I was going to run 2 sessions and my ADACOM was 20,000, my individual sessions could be 10,000 or less. Or I guess the better way to say it is if my NU parameters in my individual sessions or 10,000, then my NU on my ADACOM session ought to be 20,000 or more, depending on how many sessions I'm running. At the time I was starting this, I was running 2 sessions. I'm now up to 3 on this database. So my NUs on my individual nuke IDs are 10,000 each. So when I first started, my NU was 20,000. It's now up to 30,000 because I'm running 3. You add new parameters to your individual databases, your database sessions for cluster services. One of them is the nuke ID parameter, so he knows which nucleus session is running, and then you tell him that cluster type is local for parallel services. If I was running cluster services, I think I would say cluster type equal remote. I don't really know, but since I'm all running all of my sessions on the same LPAR, my cluster type is local. I'm running cache type and virtual storage of 64-bit, and the next 2 parameters are really, really important, the cluster cache size and the cluster lock size. There are several different formulas out there. There's one in the documentation. You can find another one if you search Empower, but I recommend strongly that you use Becky's formula, which is even different, and I've got it here in the slides. I'm also going to write in my cluster cache only the blocks that I'm changing. I'm not going to cache blocks that I'm just reading. I'm only going to cache blocks that I'm changing. So cluster cache unchanged is no. It's kind of a negative logic thing. And I always want to have Adabase automatically merge my command logs. He does this automatically. You can't determine it for P-logs. He always merges those. But you could decide whether you wanted to merge the P-logs yourself or have Adabase do it. I strongly recommend that you have Adabase do it. So here's your formula for your cluster cache size. It really depends on whether you're running Adabase caching or not. We found out that our caching wasn't as efficient as we needed to, so at the same time we put in Adabase parallel services, we turned off most of our caching and let the cluster cache handle most of our work. We've increased our buffer pool a couple of times since we put this in, and so each time we do this, I have to double check the formulas for my cluster cache because the cluster cache is dependent upon the size of the Adabase buffer pool. The cluster lock size is for the locking manager. As you update records and put them on hold in one nucleus session, he manages them in the global lock manager so that if one session is locking a record, another session can't come and grab it. So this is really important. If the lock manager size is too small, the Adabase sessions won't come up at all. And you'll get this lovely message, ADAX69, and double check your formulas and make sure that you're computing things correctly. I actually built a spreadsheet because I couldn't do the arithmetic myself. The one thing that's also important to know is the global areas are not persistent. When you bring up an Adacom router, the global areas don't start until you start your first database parallel nucleus, and that nucleus connects to the router and builds the global areas. When you shut down the last parallel session, these global spaces go away. So they're not up when the router's up, they're up when the database nucleuses are up. Another thing I learned is that Adacom must come up first and it must go down last. So however you name your routers, make sure that your automation brings them up first and ends them last. And you can run Adacom even if you're not running a database, and that's really nice when you're going back and forth between parallel sessions and single sessions, that you can leave your Adacom router up and bring your database back and forth. If your Adabase nucleus session has been up before I'm sorry, I'm recovering from bronchitis, so occasionally I'm going to stop because I might cough. When your user session starts, Adacom will direct it to a parallel session based on how many active users there are, and that user session will stay in that Adabase parallel nucleus until that session issues close commands. So it's pretty nice. Your batch natural sessions are going to stay in one nucleus session pretty much until they end. If you're running batch COBOL, that depends on how your COBOL programs are written and when they issue close commands. And your online natural sessions will pretty much also stay assigned to the same session, but it depends on the kinds of commands they issue and when they do their closes. Adacom doesn't try and balance commands, he balances users. So if you have a batch job that's running lots and lots of commands, he might end up being assigned to the same session where another batch job is running. And that's a little tricky to manage, but you can do it. We've been able to force batch jobs to particular nucleuses by issuing console commands. If you want to know how to do that, I had to ask Rich. But for the most part, your batch and online sessions are going to get routed just based on the number of users and the formula that the nucleus runs. One other thing to know is that you can run multiple databases with different DB IDs in parallel, and they can all be managed by the same router. And in fact, we're doing that. We're running database 11 and 15 now through the same router because the overhead is actually at the router level, not at the parallel sessions. And here's the statement about the NUPARM in the individual database sessions and its relationship to the NUPARM in the router session. When I was first starting this, I was having a lot of problems, and as I switched back and forth between single session and parallel session, I had to make sure that the session that came down cleanly before I could start it back up in a different mode. So if I was running parallel and it crashed parallel, then I had to restart it parallel to clean up all of the DIB entries and get the PPT back in line so I could take it down and then bring it back up single. So there were a couple of tricky moments, but as you're swapping back and forth, just note that the last session that was up needs to come down cleanly before you bring it up in a different mode. I'm not going to go through all of this because there's a whole lot here about the PPT. But this is something that happens in Adabase regardless of whether you're running single session or parallel session. He builds 32 contiguous blocks in the associator where he'll keep track of database IDs. A single session database is always nuke ID 0, and it's always in block 1 at the PPT. Parallel sessions will come up and be assigned the next available block in the PPT. And if the database has been up before and he can find an entry in the PPT, he'll reuse it. If that nuke ID has never been up before, then it'll get assigned to a new block. And the PPT keeps track of work and CLOG and PLOG data sets. I'll show you an entry here. And you can see the PPT entries in AOS or in AdaRep. So here's an AOS display of a single session PPT. Notice it's nuke ID 0, so this tells me it was a single session. And these are the names of the data sets, work, PLOG, and if I was running CLOGs, they'd be in here too. This is a PPT entry for a parallel session, and I am running CLOGs there. So notice that not only do I see a nuke ID of 1101, I see the work, PLOG, and CLOG data set names that he will then pick up these names and dynamically merge them in when he's doing PLOG or CLOG switches. And by my own naming convention, since this is nuke ID 1, all of the data sets end in an A. If this had been nuke ID 2, all of the data sets would end in a B. One important thing on your parallel sessions, they all have to run with the same PLOG required parameter. They're either all required yes, all required no, all required force. And that when a PLOG switch, AdaRes is going to read the PPT to dynamically add the PLOGs from all the other sessions. So whether I'm running 2 sessions or 4 sessions, when one session PLOG swaps, all of the other PLOGs can swap at the same time. And all of them will be dynamically merged together based on the timestamp of the swapping session. The parallel PLOGs have a timestamp on them, and AdaRes will use this timestamp to decide whether to merge them in or to leave them out of this particular merged data set. And then the timestamp is removed when the actual P-logs are written out into the P-log tape. There are some new options for P-log copies and AdaDBS commands, and here's one thing that's really, really important. You can use an AdaRes PL copy, no PPT, if you're wanting or having to create your own P-log merges if your PPT is trashed. In this case, you've got to be able to specify the names of all the data sets yourself in your own JCL, so you've got to be really careful when you do that. The other thing with AdaDBS, you can reset the PPT to erase all the information. And if you do this, then you can't use some of the automatic merging. We actually do use this feature when we flash copy our database, our operational database, into one of its clones in production or development, but we don't ever want to run this against our main database because then we would lose the information about the data sets for P-log switches. But it's a really nice feature to use if you ever are doing flash copies to copy one database into another. You have to be able to reset the PPT. There are some other operator command changes that you can add global parm to the end if you want to have this command affect all of the databases that are running in parallel. For database termination commands, you can bring down one specific database with your AdaEnd command or your halt or your cancel, or you can bring them all down. So if I wanted to bring down all of my parallel sessions, like at IPL time, I could put the global option on the end of my AdaEnd command and all of my databases will come down. Or I can issue commands specifically to one nucleus, like with the dstat command, by specifying that nuke ID. One thing that's really important to know is you can't run any of the parallel databases as UTI only. It just doesn't work. When we were installing this, I ran into some problems. If you're running Secure Tree, you have to get a special ZAP so it recognizes the Adacom utility. You also need to make sure we were running Adabase 824 and we needed some additional ZAPs for caching. So I listed them here. The AH822013 was needed to resolve some SOC4s and some SD Charlie 2 add-ins that we were getting. And I also needed AL822010 for some unexpected cache errors. As part of our flashing, we run the AdaDBS transaction suspend function, and when you do that, we needed this one ZAP. We suspend transactions during the hour it takes to flash copy our database, and then we resume them. So if you don't do flash copies and suspend transactions, you don't have to worry about the AL822010. We also were getting a really strange problem, a response 144, in our trigger programs. We use Adabase triggers to update log counters on updated records so that they don't have to do a whole bunch of rereading. They can look at a log counter to know if a record's been updated during a long, complicated update process. The way this data runs in this agency, they read the data, they decide whether they're going to want to update it, and when they want to update it, they go back and reread it to see if the log counter has changed. And the trigger programs had both the long name and the short name for the field being updated specified in the program, and the documentation clearly tells you not to do that. In single session mode, it didn't seem to cause any problems, but in parallel session mode, that did, and we were getting some really bogus 144 errors. So if you're getting those, take a look at your trigger programs. We also had a really strange problem when we first put parallel sessions into production, where we had 10 jobs that ran concurrently, each processing a portion of update transactions against the same set of files. So they were 10 jobs running concurrently, doing updates to the same files, but using different segments of data. And this happened twice, that 2 of these 10 jobs swapped out and never came back in. I was able to reproduce it in development and once in production, but we haven't had this error in over a year. So I don't know if it was something just with data or something in the operating system, but I really don't think it was part of parallel services because it hasn't happened again, and we do these splitter jobs all the time, in fact, daily. We did successfully implement parallel services in production on June 7th. We met that goal. And the testing during the month of June on our old processor showed that the parallel sessions, the performance was comparable to the single session nucleus or slightly better sometimes. So our customer agreed on July 2nd to accept the smaller box, the 2817406, and we upgraded the CPU as scheduled on July 13th. I must admit, without the help of Becky Albin and David Eichley in Denver support, I wouldn't have been able to do this. Denver support was very, very critical, working through all the problems we had and answering the numerous questions I had. For the results, we've been watching this very carefully since we installed, and our average CICS response time on our new box with parallel services is as good as it was before, and in fact right now it's better. We've continued to do all kinds of tuning. So our average CICS response time is still about 0.03 seconds. Our batch jobs are running just a little longer, but our batch schedule still completes within our window. The required guarantee was to complete all of our batch schedule before 6 a.m., and we are doing that. Most days our batch schedule is finished by 1 a.m. CPU-intensive jobs that do sorts and merges are most impacted by the smaller engines, and that's where we see the longest delays. We don't really see much overhead from Adacom showing up in our system unless our entire CPU is very, very busy, over the 90% utilization. Then we can see some additional resources being used by Adacom coming in at that point. And our capacity guy calls that the saturation design point at 90% CPU utilization. What we have seen in benefits of the system is that the larger CPU we estimated would cost us an additional $1 million in licensing fees, and by going with a smaller box, we avoided that cost. We are actually seeing some better throughput as we're running 2 and now 3 parallel sessions in our main operational data. Some of our splitter jobs, the ones that we're running concurrently, we're actually getting some better throughput of data. The unexpected benefit was the redundancy, that we are no longer dependent on a started task. So if one of the parallel sessions goes down, we still have the databases up. So we've really improved our reliability and are no longer quite so worried about database failures, even though that was never really a problem. We've also been able to add parallel sessions to provide even better performance. When we realized 2 sessions weren't quite doing the jobs, it was very easy to add a 3rd session. And in the second database that we've run in parallel, database 15, we run that normally 2 sessions all the time, but in the first of the month when we're doing some really peak processing, we run 4 sessions for 1 week, and then we take those 2 extra sessions down and go back to just running 2 all month long. The flexibility of having a database up all the time has been really nice because we actually have multiple databases running. We can take one down to change a parameter or to apply a zap, bring it up, take another down, apply the same change, and bring it back up. So we can actually do some changes now mid-month that we couldn't do before because we can bring one session down at a time and apply that change. And so that's really been a nice benefit of the parallel sessions. When we were running single session mode, we had 1 week in a month that we could change things. So our plans have been to change our system file database to run in parallel sessions. It's really kind of odd that as soon as our parallel sessions came up, we were having this checkpoint meeting afterwards with our customer to talk about how great everything was running, and everything was running great on the new sessions. We were just about, we were giving everybody hand slaps and handshakes and dancing around the room, and then we got a call from the help desk that said the databases were down, and we found out that our system file database had crashed, not our parallel sessions. And so one thought we really want to do is to bring our system file database up in parallel so that we will never, ever have to worry about it crashing and taking down all of our database access. So we had a 10-minute outage right after we went parallel, but it wasn't anything to do with parallel services. As I said, we have run a third session now in our main operational data, and our performance is even better and our throughput is even better. We've done some adjustments in Workload Manager to sort of simplify Workload Manager rules, and that's helped our performance. We just turned HyperDispatch to yes, and that's helped our performance. We've increased our buffer pool again. We're now running a buffer pool of 300 meg on each of the sessions, and that's helped our performance. What we're in the midst of doing right now is installing new storage hardware. We're going to a new class of disk drives that'll be better performance than our current ones, and we will finish that this summer. So my conclusion is everyone who has Adabase parallel services should run it if they want to improve the reliability and the redundancy of their database and give them a little bit more flexibility on doing maintenance, because with Adabase parallel services you can take sessions down and still have your database running. And so you can do database maintenance without impacting your users. It's been a really good thing for my customer. So I am concluding my presentation, and we'll open for questions.
Thank you. We'll now begin the question and answer session. If you have a question, please press star, then 1 on your touch-tone phone. If you wish to be removed from the queue, please press the pound sign or the hash key. There'll be a delay before the first question is announced. If you're using speakerphone, you may need to pick up the handset first before pressing the numbers. Once again, if you have a question, please press star, then 1 on your touch-tone phone.
Steve Kendrick, I know you had a bunch of questions before the presentation. Did I answer any of them?
Actually, Craig from OPM just queued up the question. Please go ahead. Craig, your line is open.
Okay, thank you. Deborah, you said you were making PARM changes
Yes.
mid-month now. Are those PARM changes to create a different performance level for particular times of the month when you run, or are these things you're running into and trying to adjust PARMs that use problems, issues, or whatever you come across?
We are just trying to improve performance. So that there's something that we, and Becky's been instrumental in this, helping us tune things and just to get better and better performance. You know, it's the problem when you're running on a smaller box. With more engines but smaller engines, you just constantly we're tweaking things to make it run better. So it's not something that we are doing just mid-month for performance. We are putting them in and leaving them in.
Okay, so you don't have 2 or 3 profiles that you run during the month and you swap them out on a Friday or a Saturday to get ready for a certain type, like a high update run or anything like that?
No, because we constantly run high update runs every single day.
Okay.
This is a very pardon me?
You're not running Ada SAF or anything like that in there.
In this site, no.
Okay. All right. That answers my question. Thank you very much.
Thank you.
And once again, if you have a question, please press star, then 1 on your touch-tone phone. And we have Chad Scott from Federated online with a question. Please go ahead.
Hi there. I think you mentioned that you removed caching or turned off caching once you started using the parallel services. Can you, I guess, elaborate on that a little bit as to why?
It was part of Becky's review, and it happened sort of as a coincidence. Based on previous presentations by Jim Poole and the recommendations that Becky and Jim make, that if your caching efficiency is less than 50% or 60%, you should get rid of it. And our caching efficiency was about 50%. So we should have done it anyways. It really wasn't a factor with Adabas Parallel Services. It just says that our caching wasn't all that effective. We just happened to turn it off at the same time since we were making a bunch of changes.
Okay, thank you.
And we have Mark Boyer from SCI Investments on line with a question. Please go ahead.
Hi, Debbie. Do you know if replication works with parallel services?
It should. It shouldn't matter because the replication is being done from your DBID, not from your nuke IDs. Is that a true statement, Becky? I'm not running replication at this customer.
Debbie, you're absolutely correct. You can run replication with parallel services. We have several customers who are doing that.
Okay, thanks.
And I just got a question on the webinar. Not sure if everybody can see this. It's from Deborah, and it says, I know nothing about parallel services yet and don't understand how she can apply changes to one parallel session at a time. Wants to know if that impacts other services that may use the other parallel sessions for the same database.
I was talking about changes, like if I was applying a ZAP to a load library, if I was doing some maintenance where you need to drop the database for that change to become effective, I could apply the ZAP to the load library, drop one parallel session, bring it back up, and now that change would be, that session would have picked up the load library with the ZAP. I could drop the other session, and it would then bring it back up, and so now my sessions would all be up with the same refreshed load library. Or if I was changing a PARM, not my buffer pool size necessarily, but I could do that too. But I could, in fact, I just did this. I increased my buffer pool size. My cluster cache size was already large enough to handle the change, so I didn't have to change that. But I could change my Adabas buffer pool in nuke ID 1, drop it, bring it up so it comes up with a bigger buffer pool size. I could make the same PARM change for nuke ID 2, drop it and bring it back up, and now they're both running with a bigger buffer pool size. So I could do that without taking my database completely out of service. I could still have online users accessing my database as long as I could stop all the transactions to the one database I wanted to take out of service. And when there were no users on it, then I could take it down and then bring it back up.
And we have
Did that
Brian.
answer my question?
If you have a question or a comment, please press star, then 1 to be entered in the audio queue. And we have Brian Johnson online with a question. Please go ahead.
Thank you. Hi, Deb.
Hi, Brian.
I know the question was asked about Adabas Event Replicator. Do you or Becky know any issues with using RRDF?
That's a good question, Brian. I don't know because it's not our product. I don't see why it would matter because RRDF is using user exit 10, I believe, right, to capture P logs. I don't think there should be any problems with that.
Okay, thank you.
And
Becky, do you want to elaborate at all about changing PARMs and dropping databases and stuff like that?
No, you covered it just fine. Was there another question?
No, we have no further questions.
This is Becky Albin from Software G. I just wanted to say thanks to Deborah for doing this presentation. She did a great job, really great job, just like she did at Innovation World last fall. If you guys have any questions at all, feel free to reach out to your local Software G representative. I know most of you on the phone, so if you want, just pop me an email. And I'm sure Deborah would be glad to talk to any of you guys as well. I just want to say thanks. Deborah, you did a great job. And Deborah, if you want to just go ahead and wrap up real quick.
Simple warned me that it was really odd doing these webinars because you weren't talking to any faces, and I must agree it was much easier to get this presentation in San Francisco when there were people in the audience to read. So I hope that I've answered questions. If not, please feel free to contact me. I would be happy to share our experience with you. It's been very, very, very positive. The documentation is very good, and it's so short I didn't think all the information was there, but it is. Once I realized that a lot of the documentation where they're talking about cluster databases also applies to parallel databases.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating, and you may now disconnect.